Welcome to another tutorial. I'm your host Fraser and this is a Create Vision video. We're going to practice the identity of matrix. Let us begin. Before we start explaining what identity of matrix is, let us get a few commonalities out of the way. You see, 0 and 1 have one commonality, which is when both of them remain unchanged in certain situations. For instance, when one person adds 0 to any element, it remains unchanged, right? And when if anyone multiplies 1 to any element, it remains unchanged. So let me explain to you the 0, how the similarity between the ordinary algebra and the matrix algebra are similar, and what conditions do they remain unchanged when 0 is added. So if you had any matrix A and D was your zero matrix. D right here was a matrix of which all the elements were 0. So if you were to add matrix A to D, matrix A will remain unchanged. So as you can see, whether D comes first or D comes second, they will both satisfy the condition of that I have added a 0th matrix and it has remained unchanged. All the elements in my D matrix are 0 and it has remained unchanged. So here's an example. The example you see in front of you is matrix A has the following elements: 1, 2, 1, 3, and D, all the elements in it are 0. And as you know, in my previous tutorials where I demonstrated to you the addition of matrices, A and D, A will remain the same. A will remain the same. Even if D comes second or like it comes first, A will remain the same because it satisfies the addition rule. Okay. In linear algebra, the identity matrix of size n is the square matrix with 1s on the diagonal and 0s elsewhere. You see, it is denoted by an I. So, and usually you'll apply it when you're timesing, when you're multiplying. So in this instance, if A is any matrix, right? And you times it, multiply it by the identity, A will remain the same. Because anything times multiplied by 1 is itself. So in this instance, D is your identity matrix, but usually you would denote it using an I. So let's verify this by giving you a typical example of how an identity matrix looks like. So I have a matrix of A with the following elements: 1, 2, 1, 3. And remember, the diagonals of the diagonal elements are 1, is 1, all of them going down, and all the other elements are 0. So when you times A by 1, as I have shown you in my previous examples, you should come up with A having the exact same similar elements. So that's what is important. You just need to remember that the diagonals elements in an identity matrix are 1 and the other elements are 0. The other elements are 0. So just remember that. For now, it's going to be basic, and I will demonstrate to you in further videos how to better use the identity matrix. Thank you for watching. Please like and subscribe.